everyone, you are welcome to my class. In this video, we are going to be looking at the first aspect of 2026 WAEC chemistry practical on quantitative analysis, that is titration. I've released the first video on salt analysis. So we are going to focus on quantitative analysis, and I'm going to explain all the necessary steps that need to be followed while answering questions on quantitative analysis. Then we are going to work on the following predicted questions on the board. Then the first aspect of this practical is dependable. Then what I mean by dependable, you have to depend on your school title value, that is your teacher's title value, to form your table. You use your school title value, don't use my own title value. You have to use your subject teacher title value. Now I'm going to teach you how to form your table. Once you know your school title value, how you are going to form your table, I'm going to teach you. So let's start with the following questions. Now, the first thing you are going to do, let's read the question on the board. A is a solution containing 1.42 grams of H2S per 250 centimeter cube. B is 0.10 mole per dm cube of sodium hydroxide. Put A into the burette and titrate with 20 or 25 centimeter cube portion of B. Using methyl orange as indicator, record the volume of your pipette, tabulate your readings, and calculate the average volume of A used. From your results, calculate the concentration of A in mole per dm cube, the concentration of A in gram per dm cube, mass of X in H2S, the number of mole of hydrogen ions in 1 dm cube of A. Then the last one is the percentage purity of B in an impure 5.3 grams of the solution. Now, what is the first thing you are going to do? You record the volume of your school pipette. Record the volume of your school pipette. You can see in the question says that record the volume of your pipette. So you record the volume of your school pipette. Pipette is in this form. So look at your pipette. You are going to see the volume on it. Then if you don't know it, ask your subject teacher. Ask your subject teacher. Now, the volume of my own pipette is 25 centimeter cube. You can see that the question says that with 20 or 25 centimeter cube. So your own can be what? 20 centimeter cube. Your school pipette can be 25 centimeter cube. But my own school pipette is 25 centimeter cube. So that is the first thing that you need to record. So volume of pipette used equal to 25.00 centimeter cube. Then your volume must be in 2 decimal places. Make sure that you record your volume in 2 decimal places. Then the next thing is to form your table. The next thing is to form your table. So the first one, you write burette reading. Then you have your rough title. The first title, the second title, then followed by the third title, followed by the third title value, followed by the third title. Now, under burette reading, you are going to write the final burette reading. Then it must be in centimeter cube. This unit is very, very important, in centimeter cube, followed by initial burette reading in centimeter cube. Then the last one is volume of acid used. The last one is volume of acid used. Now, my own school title value is 21.90 centimeter cube. Make sure that you use your school title value. So 21.90 centimeter cube. Then I'm going to work based on this 21.90 centimeter cube to form my table. And I'm going to make use of plus or minus 0.2. I'll make use of plus or minus 0.2. Now, to get my first table, to get my first record under rough titration, your bill rate starts from 0. So your initial bill rate reading will be 0.00. So make sure that everything that will be recorded in this table is in what? In 2 decimal places. The volumes must be recorded in 2 decimal places. So my initial reading is 0.00. Now I'm going to start with my original title value, that is my school title value. I'm going to add 0.2 to this title value. So when you add 0.2, it will give me 22.10. 22.10. Now, let's move to the next column, the next titration. My initial reading for the next titration will be where I stopped from the first titration. My initial reading will be where I stopped from the first titration. So I'm going to make use of the remaining acid in the what? In the burette to carry out the next experiment. So my initial reading, that is where I stopped here, will be my initial reading. So 22.10. 22.10. So what will be my final burette reading? What will be my final burette reading? I'm going to make use of plus or minus 1. Plus or minus 0.1. But don't let it exceed plus or minus 0.2. Don't let it exceed plus or minus 0.2. So I'm going to make use of this plus or minus 0.1. I will start with plus 0.1. I'm going to add plus 0.1 to this my original title value, that is my school title value. Add 0.1 to this title value will give me what? Will give me 22. 22.00. That is 21.90 plus 0.1 will give me 22.00. Now to get my final burette reading, I'm going to add this 22 to 22.10. So 22 plus 22.10 will give me 44.10. Now 44.10 minus 22.10 will come back to this 22.00. So you must come back to what? Your title value that you want to use. Now this one will give me 22.10. That is 22.10 minus 0.00 will give me 22.10. Now to form the next one, so I have 44 in my burette. Then the volume of burette is always 50. So it shows that the remaining acid will not be enough for you to continue the next what? To complete the next experiment. The acid left will not be enough for you to complete the next experiment. So you have to fill it up. So when you fill it up, your initial reading for the next one will now be 0.00. Now, I started with plus 0.1. So the next one will now be minus 0.1. I'm going to minus 0.1 from my school title value. Take away 1 from this 21.90 will give me what? Will give me 21.80. So 21.80 minus 0.00 will give me 21.80. Then the next one. So if you like, you can still fill it up. If you like, you can fill it up. If you like, you can start from 21.80. So your initial reading here can be 21.80. Or you what? Or you fill it up. Then you start from 00. So now I'm going to make use of this exact value. I'm going to make use of this exact value. So that will be 21.90. So 21.90 minus 0.00 will give me 21.90. So we have completed the table. Then the question says that tabulate your reading and calculate the average volume of acid used. Then don't forget that this is volume of acid used. Now you are going to calculate the average volume of acid used. So that will be average volume of A used equal to, don't use the value that you have under rough title. Don't use value under rough title. So you are going to start from here. 22 plus 21.80, then plus 21.90, then divided by what? You use how many values? 3 values, so divided by 3. So by the time you divide this by 3, the volume of acid used, VA is the volume of acid used. So the volume of acid used will be equal to 21.90 centimeter cube. That is, add everything together and divide by 3. You are going to come back to 21.90 centimeter cube. That is your school title value. So let's move to the next question. So the next question says that from your result, calculate the concentration of A in mole per dm cube. Calculate the concentration of A in mole per dm cube. So let's bring out all the parameters in the questions. Let's bring out our parameters. So from the question now, we have A is a solution containing 1.42 grams of this unknown acid per 250 centimeter cube. Then for this year titration, we have titration between H2SO4 and sodium hydroxide. But our acid is unknown from the question. Our acid is unknown from the question, but our acid for this year is what? H2SO4. So it shows that this what? This is an unknown acid. So reaction between this H2SO4 and sodium hydroxide gives this. Now let's proceed. So A is a solution containing 1.42 gram of this unknown acid per 250 centimeter cube. Then anything in gram is mass concentration. But this mass concentration is in what? In gram per 250 centimeter cube. Then our mass concentration must be in gram per dm cube. Mass concentration must be in gram per dm cube. So this is mass concentration. So you are going to write it as mass concentration of what? Mass concentration of acid. So let's say mass concentration of A equal to 1.42 gram per what? But per 250 centimeter cube. It's not in gram per dm cube. Per 250 centimeter cube. Now before you use this mass concentration to calculate anything, you must convert it to what? To gram per dm cube. It must be converted to gram per dm cube before you use it. Now let's proceed. Put A in the burette and titrate with then the volume of base. Our own volume of base is 25. That is the volume of pipette used. The volume of pipette used is the volume of base. So I'm going to write it as VB equal to 25.00 centimeter cube. That is the volume of pipette used. The volume of pipette used is the volume of base. Now we have gotten the volume of acid. That is VA. So let me write it. VA equal to 21.90 centimeter cube. Now let's proceed. Is there any other value? No. Now from this equation of the reaction, we can get the number of mole of acid. We can get the number of mole of base. What is the number of mole of acid? That is the coefficient of this acid, which is equal to 1. The number of mole of acid equal to 1. Then what is the number of mole of base? That is the coefficient of this base, which is equal to 2. Let's call it NB equal to 2. Now we can proceed now. Then the question says that calculate the concentration of A in mole per dm cube. Anything mole per dm cube is the molar concentration. So we are looking for the molar concentration of acid, that is A. So let's write it as Ca. So Ca is unknown. So what are we going to use to look for the molar concentration of acid? Since we have the molar concentration of base, they've given us the molar concentration of base. 0.10 mole per dm cube is the molar concentration of base, because anything in mole per dm cube is the molar concentration. So the Cb equal to 0.10 mole per dm cube. Now let's proceed. So since we have the molar concentration of base, then we have the volume of acid used, the volume of base used, the number of mole of acid, and the number of mole of base. We are going to use our general formula. So Roman figure 1, you use CaVa equal to Na divided by Nb, then divided by CbVb. CaVa divided by CbVb equal to Na divided by Nb. Then we are looking for the what? The molar concentration of acid, which is Ca. So make Ca the subject of the formula. Make sure you don't jump any step. Make Ca the subject of the formula. So Ca will be equal to CbVb multiplied by Na, then divided by Va multiplied by Nb. So which is equal to what? What is Cb? That is 0.10, then multiplied by Vb. Vb equal to 25, then multiplied by the number of mole of acid, which is 1, then divided by the volume of acid, which is 21.90, then multiplied by the number of mole of base, that is equal to 2. That is equal to 2. So let's proceed. So what will be our final answer for that? 0.10 times 25, then divided by 2, then divided by 21.9, that is equal to 0.057. So our Ca equal to 0.057. Then molar concentration must be in what? In mole per dm cube. This unit is very, very important. Then make sure that your molar concentration is always in 2 significant figures or 3 decimal places. Make sure that your molar concentration is in 2 significant figures or 3 decimal places. So we have answered what? We have answered question 1. Let's move to question 2. Let's move to question 2. So question 2 says that calculate the concentration of A in gram per dm cube. Calculate the concentration of A in gram per dm cube. Is there anything given on this what? On this A? We have the mass concentration of A in gram per centimeter cube, and they say that calculate the concentration of A in gram per dm cube. That is, we are looking for the mass concentration of A in gram per dm cube, but they've given us the value in gram per centimeter cube. So what we are going to do is to convert this to what? To gram per dm cube. We are going to convert what we have here to gram per dm cube. So question 2. So to convert it to gram per dm cube, now we are looking for mass concentration in gram per dm cube will be equal to what? 1.42. 1.42, that is mass multiplied by 1000, then divided by 250, divided by 250. Don't forget that 1 dm cube is equivalent to 1000 centimeter cube. So you multiply by 1000, then divide by 250. So it will give you what? What will be our mass concentration in gram per dm cube? That is 1.42 multiplied by 1000 divided by 250. So our answer equal to 5.68. 5.68 gram per what? Per dm cube. 5.68 gram per dm cube. Then we have gotten our molar concentration. Let's write it because we are going to make use of the molar concentration. We got 0.057 mole per dm cube. Now we have gotten our mass concentration in gram per dm cube. So let's write it out. Our mass concentration in gram per dm cube, we converted what we have here to gram per dm cube, so which is equal to 5.68 gram per dm cube, because we are still going to make use of the following values. Now let's move on. Let's move to Roman figure 3. Let's move to Roman figure 3. Now, in Roman figure 3, we are looking for the mass of X in this unknown acid. Now, to find the mass of X in this unknown acid, we have to calculate the molar mass of the acid. We are going to calculate the molar mass. Now, molar mass first. Molar mass in gram per mole equal to mass concentration in gram per dm cube, then divided by molar concentration. The molar concentration in mole per dm cube. So we are looking for the molar mass. So this is the formula for calculating molar mass. Then you can also use this formula to look for mass concentration if mass concentration is not what? Is not given. Now let's proceed. So what is our mass concentration? Don't forget that we are looking for the mass concentration of acid. So we are going to use what? The mass concentration of acid. Mass concentration of acid equal to 5.68 gram per dm cube. You use the one that you have converted to gram per dm cube, not the one in what? In centimeter cube. So our mass concentration equal to 5.68 gram per dm cube, then divided by what? The molar concentration of acid. What is the molar concentration of acid? 0.057. 0.057 mole per dm cube. So which is equal to what? 5.68 divided by 0.057. That is 99.6. So that is 99.6 gram per what? Gram per mole. This unit is very, very important. No mark for what? No unit. No mark for no unit. So your molar mass is always in gram per mole. That is not where we are going. What we are looking for is the what? The mass of X in H2X. Now to calculate the mass of X, we are going to say H2X equal to the molar mass. The molar mass of this acid equal to 99.6. Equal to 99.6. Now you are going to add the mass of each atom together to calculate the value of X. Add the mass of each atom that present here together. So that will be 1 times 2 plus 1 is the molar mass, the atomic mass of hydrogen. Then you have 2 atoms of hydrogen. That will be 1 times 2 plus X equal to what? 99.6. Then you make X the subject of the formula. X equal to what? 99.6 minus what? Minus 2. 1 times 2 will give you 2. So which is equal to what? 99 minus 2, that will be 97.6. So 97.6 what? Gram per mole. 97.6 gram per mole. So now question 4. Let's move to question 4. So question 4 says that calculate the number of mole of hydrogen ion. Calculate the number of mole of hydrogen ion in 1 mole in 1 dm cube of A. Number of mole of hydrogen ion in 1 dm cube of this unknown acid. So you are going to write dissociation of that unknown acid. You are going to write dissociation of this acid, H2X. An acid produces what? Hydrogen ion. An acid produces hydrogen ion. So this one will give you what? 2 hydrogen ion. We have 2 hydrogen ion plus X2 minus. Plus X2 minus. Now, 1 mole of this acid, 1 mole per dm cube of this acid, the coefficient of this acid is 1. So 1 mole of this acid produces what? 2 moles of this hydrogen ion. Produces 2 moles of this hydrogen ion. Now we have gotten the what? The molar concentration of the acid, because they say in what? In mole per dm cube. We have gotten the molar concentration of acid to be 0.057. So you are going to say 0.057 mole per dm cube will now be equal to X. You are going to calculate the number of mole that is equivalent to this what? 0.057 mole per dm cube. So you cross multiply. So to get the value of X will be equal to 0.057 multiplied by what? Multiplied by 2 will give you what? Don't forget that you are looking for the number of mole. 0.057 then multiply by 2 equal to 0.114 equal to 0.114 what? Mole. Because we are looking for the number of mole. X is the number of mole equivalent to what? 0.057 mole per dm cube. And that is not where we are going. We are looking for the number of mole of hydrogen ions. We are looking for the number of mole of hydrogen ions. Then we should not forget that 1 mole of any atom or 1 mole of any ion is equal to the what? Is equal to Avogadro's constant. That is the next step to take. 1 mole of any ion is equal to Avogadro's constant. Now we are going to say 1 mole of hydrogen ion equal to Avogadro's constant. Then Avogadro's constant is a constant value. That is 6.02 times 10 raised to the power 23. So what will now be the what? What will now be the number of ions? Then the Avogadro's number is the number of 1 mole of any ion. So we are going to call this what? Ions. So, and I've gotten this number of mole, the number of mole for this 0.057 mole per dm cube. Now you bring this number of mole in, 0.114 mole of hydrogen ion will now be equal to what? Will be equal to X. So I don't know the number of ions that will be equal to what? This 0.114 mole. Then you cross multiply. When you cross multiply, 1 times X will give me X equal to 0.114 times 6.02 times 10 raised to the power 23. So what is the final answer? So times 6.02 then multiply by 10 raised to power 23. So our answer equal to 6.862. X equal to 6.862 times 10 raised to power 22 ions, because you are looking for the what? You are looking for the number of mole of hydrogen ions. Then you have to rewrite it. You have to rewrite it that the number of mole of hydrogen ions in 1 dn cube of A equal to this final answer. The number of mole of hydrogen ions in 1 dn cube of A equal to the final answer. Now, let's answer the last question. Let's answer the last question. So the last question says that calculate the percentage purity of B in an impure 5.3 grams per dn cube of the solution. That is the percentage impurity of sodium hydroxide. B is sodium hydroxide. Then they've given us the mass of an impure. So mass of impure equal to what? Mass of impure equal to 5.3 gram per dm cube. Then we are going to need mass of pure. We are going to need mass of pure. That is, the mass of pure is the mass concentration of B. Is the mass concentration of B. Then let's look at the parameters given. There is nothing like mass concentration of B. So we have to look for the mass concentration of B. Now, mass concentration of B in gram per dn cube equal to what? The mass concentration will be equal to molar concentration, then multiply by the molar mass. So molar concentration multiplied by the molar mass. Then the molar concentration of what? That is the molar concentration of base. Then the molar concentration of base equal to 0.10. 0.10. Then we don't know the molar mass of base. We don't know the molar mass of base. But our base is sodium hydroxide. Now, before we make use of this formula, we have to calculate the molar mass of base. So we are going to look for the molar mass of sodium hydroxide, which is equal to the atomic mass of sodium, 23. The atomic mass of oxygen is 16. Then plus the atomic mass of hydrogen equal to 1. Then equal to what? 40 grams per mole. Molar mass is always what? 40 grams per mole. So you have to show that before you proceed. Now let me calculate my mass concentration now. So mass conc in gram per dn cube will be equal to the molar concentration of base. The molar concentration of base equal to 0.10. 0.10 multiplied by the molar mass. The molar mass equal to 40 multiplied by 40. So which is equal to what? 0.10 times 40 will give us what? 0.1 multiplied by 40. That is 4 grams. 4 grams per dn cube. So this 4 grams per dn cube is the mass of pure. This 4 grams per dn cube is the mass of pure. So I've gotten the mass of pure. I'm going to need the mass of pure to calculate the percentage purity. I'm going to need the mass of pure to calculate the percentage purity. So mass of pure equal to what? Equal to 4 grams per dn cube. Now we can calculate the what? The percentage purity. Then don't forget that When the mass of an impure is given, don't use the mass of an impure to look for molar concentration. Don't use mass of impure to look for molar concentration. Now let's proceed. Now to calculate the percentage purity equal to mass of impure minus mass of pure. Then divided by mass of impure, then multiply by 100. So mass of pure minus mass of impure. Then what is the mass of impure? That is 5.3. 5.3 minus the mass of pure. Mass of pure equal to 4 grams. Then divided by the mass of impure equal to 5.3. Then multiply by what? Multiply by 100. Multiply by 100. So let's get the final answer. Let's get the final answer. 5.3 minus 4. That is 1.3. Then divided by 5.3. Then we multiply by 100. Multiply by 100 equal to 24.5. So percentage purity equal to 24.5 what? Percent, because we are looking for the percentage purity. So that is the final answer. So we have come to the end of this class. Please don't forget to like, share, and leave comments. Please let's leave comments and let's share this